SwayamPrabha. Digital India. Educated India.
Welcome everyone. We are in the last lecture of module 2. So, we started with wood. In the previous lecture, we tried to understand engineered wood. So, these are all being used, readily available in the market, and they are all acknowledged by our codes, standards. So, all plywood what we discussed, MDF boards what we discussed have an ISI stamp. Wood also, particular types of wood have their stamps. They are recognized by Government of India. Across the country, if we move into the rural areas, we see most of the houses we use bamboo. Particularly in this tropical climate, it is a grass. We have discussed bamboo also when we were doing the classification of trees. It was an endogenous tree. It was endogenous plant. It is a category of grass, and it grows and at a particular rate on the upper side, on the longer side, vertical direction, and every time it moves there is an internode distance, and then there is a node formation, and then again a particular length, again a node formation, and it grows longer and longer. This has been used traditionally for supporting roofs. It has been used as wall supports. It is used as a support in scaffoldings of any urban scape, any urban construction. You can see use of bamboos as props, supports to hold the plywood in position when it is a roof casting, when it is a concrete casting. So, structurally, strength wise, it is very usable, people are confident in using it, but even then it takes a long process to enter into the code. Yes, it structural, as a structural member, it is now being included in NBC, National Building Code 2016, SP 7 includes it. So, we will go through its advantages, limitations and some applications. In China, in Malaysia, in such tropical weather conditions, it is being used as for construction purposes. So, it is a secondary member in our building industry. So, it is a low cost temporary material and is used majorly as a support in construction system, but recently it is being used, it is being explored, it is being researched, and it is getting its popularity, gaining its popularity, though the durability, lack of structural design data, lack of proper joineries has restricted its further use. So, one member, bamboo member crosses one bamboo member, it is not cut. So, there is no joinery as we had in case of wood. So, there are certain limitations. One does not make the joint weak, and at the same time it is temporary, it is not, it may not happen in the same position next time. So, why to cut it? If you cut it, what should be the way to cut it? So, those things are now getting into the code and it is gradually becoming popular and being used, getting into practice. So, what does it have? It has a internodes transverse direction which actually acts as stiffener. So, at a regular interval it is having a stiffener kind of thing which actually gives it support. So, if you see the bamboo like this, it will be inside, here you cannot penetrate further. So, this is closing, this is connecting. So, otherwise it is a hollow section, in section it is hollow. But at these points, these are like ridges. So, bamboo culm is the tubular structure consisting essentially of its nodes and internodes, that is called a bamboo culm. In the internodes, the cells are axially oriented, similar to fiber, similar to wood fiber. You see the fibers are in the longitudinal direction and the nodes are preventing it in the transverse direction. The disposition of the nodes and the wall thickness, that is the thickness of the bamboo, are significant in imparting the strength to bamboo against bending and crushing. Hence, it is suitable for spanning as a spanning material. It can be used for bamboo as a truss, bamboo for roof holding, framework, tiled roof. Bamboo can go as a continuous beam member in foundation, and by splitting it, you can make it usable for giving strength. So, bamboo splits half culms. You can split it in the longitudinal direction. So, it needs proper workmanship. So, you can actually slice it into two halves. I will come to some pictures. And you can slice it further to get slivers. Those are also quite rigid, quite strong, and they can bend. You can make wall with it, the support system within a wall with it. These are called bamboo slivers. So, after knowing these terminologies, let us see what are the advantages of it. As I told you, it grows in the longer direction. It is a fast growing grass. It grows 30 centimeter, that means 1 foot to 1 meter in one day. Extremely strong, natural fiber. Obviously, being natural, it has all the disadvantages like wood, that is, it may be affected by termites, it can absorb water, and you have to check those. It is at par with hardwoods, and the strongest part are those nodes where the transverse supports are there, and it is so close, it gives it the entire strength and stability. A large number of species are found, and mostly, as I told you, it is used for scaffolding, but bamboo is highly flexible too. You see this particular picture where the bamboo has grown in a trained way. So, if you want to make a bamboo arch, you can actually make it by training it. You can create such kind of arch just by giving it a way to grow in this direction and allow it to grow in this direction. You can, after it gets matured, you can cut it and use it for your purpose. So, walls, arches can be made with help of trained bamboo. It is a shock absorber, particularly useful for earthquake prone areas. And finally, the most advantage is it is growing, it is a tropical grass, it grows much in number, light in weight, hence it is cost effective. You see, any kind of temporary structure which till date crops up is all made of bamboo. Any festival pandals, any fair kiosks, you will see the extensive use of bamboo. As it is light in weight, you can carry it for distances by human carts and they can be transported. You use it for as props, for holding as a scaffolding. So, these are the major advantages of it. Now, let us come to the limitations. You can see the red bullet points: joining techniques, flammability, lack of design guidance and codification. So, traditional joints exist, but they are structurally not efficient, and that is why not put into code, because who takes the responsibility? So, proper joining techniques are to be developed, were to be developed, which are now being developed or researched. Flammability, yes, similar to wood, bamboo is also not fire resistant, they are highly flammable, and you have to either treat it with proper paint or you have to embed it so that it is not exposed to fire, and then only you can use it. And coming to the last point, it does not have proper codes to be followed as a structural member. Though it has lot of or equivalent to wood, it has not come so much into the codes because there is not much design guidance. Lot of embedded, that is bamboo as a reinforcement, has been started nowadays. Researches are being made, it is being embedded to replace iron rods. Yes, the span may be limited, you cannot go longer. So, lack of guidance has restricted for its codification, but yes, researchers are working on it to bring it to the forefront of building construction. So, let us see some joints. These are some cuttings. You can see on the upper side, you see a number of cuttings, 1 ear, 2 ear, bevel that is played at 45 degree, flute like. So, one side is half is at the same level, that is a horizontal level, and part of it is beveled, and this one is the most used, which is called fish mouth. So, this is giving a circular profile which can, you can see, which can sit with on top of another member. So, these are composite bamboo concrete foundations. This is a single foundation and this is a strip footing. So, this is a continuous footing that is in the foundation. You can see at the edge or the corner where it is going to take the load, here it is strengthened by more members. So, this is the continuous member, and you see the cuttings are being done. Now, how to fix it? You see the grouting of rods in the column. You can see reinforcement rod here that can actually be there, go and get embedded inside the concrete. So, these are details being developed. Architect Laurent Fournier works in Kolkata area, where he has developed this kind of grouting methods. He has made cold storage in the rural area with bamboo. So, experimentations are being done. Let us see some more. Here you see the slivers, the bamboo slivers, which are woven to form the bamboo wall. Now, what has happened? After making this wall, it has lots of holes. So, it will not give the protection for which a building is being made. Air will pass through, privacy will be disturbed, it will allow water inside, it will decay. So, now you put a plaster on top of it, mud plaster. Rural areas, you see in between you are strengthening it with means of full bamboo culms. So, these are put inside and the woven bamboo matrix is passing, on top of which you are plastering. So, you are not allowing air, visibility, water to touch this bamboo sliver wall. Another interesting, you can see another interesting way of making a wall is with half culms. Now, how are they joined? If you can recall, putting the tiles, over tile and under tile. See, they have cut it and they are actually pushing one, supporting one within the other. Again strengthening it with half culms at intermediate distances, as you can see here also. They are protecting it. They are fastening it from this end to that end by straps, so that they do not move, and then they can cover it with mud or they can keep it such like that to give it an aesthetic appeal, give it a rural setting. So, you can use such kind of details for making a boundary wall of a, say, rural tourist center. Here you can see this is a bajrak wall where the inside is mud, and to strengthen that mud wall you are intermediately putting bamboo splits, split bamboo, not as thin as the slivers, but something in between half culm and the sliver. So, these are split bamboos which are placed to reinforce the mud wall. So, after putting, they are supported with plaster, they are again covered with plaster to keep it protected from the weather. Inside, at intermediate locations through the mud wall, you can even put columns of bamboo. So, in all these cases you can see bamboo has been protected by a layer of plaster. It may be mud plaster, but it is keeping it protected from the moisture and also termite attacks. Other way is, if the bamboo goes underground, you can put coal tar. That gives it a impervious cover, impervious layer. Water does not penetrate inside it. So, with these we can say that yes, in the future we as architects can also experiment or can go or recommend bamboo as a building material for, even if it is low cost construction, it should be having proper tests and it should be within our code. So, let me come to the end of this particular module and I leave you with some assignments which actually is considering all the 5 lectures. Some are from wood, as you can see, few of the questions are from wood, few of the questions are from plywood, engineered wood and the bamboo part. So, you can try all these, hopefully you can answer all these and any questions can be raised in the portal. Thank you.